300 million years ago, a creature the size of a large hawk was flying through the sky. But it was not a bird. Birds simply did not exist in that distant era. Their appearance was still tens of millions of years away. This was an insect with a wingspan of nearly 70 centimeters. It hunted right in the air, snatched its prey in flight, and had not a single equal rival in the sky. Today, the largest dragonfly fits comfortably in a child's palm and frightens absolutely no one. But back then, the air was ruled by a creature truly worth fearing. So, what happened to these giants? Why has the sky above us never seen anything like them again? The answer lies not in the creatures themselves at all. It hides in the very air that the whole planet breathed back then. And to understand their fate, we have to return to a world we simply would not recognize today. This is the Carboniferous Period, an era of endless swampy forests and stagnant warm water. The Earth is covered with thickets as tall as apartment buildings, stretching all the way to the horizon. But these are not the trees we are used to. Their trunks are almost devoid of real wood. They grow swiftly and just as swiftly topple into the black mire. The air here is thick, humid, saturated with the smell of rotting plants and standing water. No birdsong, no voices of beasts, only the rustle of leaves and the hum of wings. And there is something in this air that no longer exists today. It contains nearly 1.5 times more oxygen than we breathe now. It was precisely this excess that created the giants of the sky. Because the size of an insect, as it turns out, depends directly on what it breathes. And this is where the most curious part of the whole story begins. To understand why the air was so rich, we need to look down at our feet. These strange trees grew faster than anything could break them down. When they fell into the swamp, the trunks did not rot, but sank into the oxygen-starved sludge. Year after year, century after century, they piled up in enormous layers. It was from these heaps that coal was later born, giving its name to the entire era. And while the plants grew, they greedily absorbed carbon dioxide and released oxygen. But this oxygen was barely used up again, since no one was decomposing the wood, and the planet's air slowly but relentlessly filled with the life-giving gas. Thus, the very chemistry of the Earth swung the atmosphere to an unprecedented level, and this imbalance became the invisible foundation for the giants to come. Insects breathe in a completely different way from us. They have no lungs. They also have no blood to carry oxygen through the body. Instead, their entire body is threaded with a network of the finest tubes. Air simply seeps inside through small openings along the sides of the torso. This method works reliably, but it has a rigid, insurmountable limit. The larger the insect, the harder it is to push oxygen deep into its body. In ordinary air, a giant would suffocate from within, unable to feed its own tissues. But in the Carboniferous forest, the air was entirely different. Its excess allowed these tubes to nourish even a huge body in full. The world itself, through its conditions, permitted insects to become giants, and for long millions of years, they took full advantage of this rare privilege. Scientists named these creatures Meganeura. Their transparent wings caught the light through the warm vapor rising above the swamp. They glided silently over the ferns, scanning for prey below and instantly changing direction. They had enormous eyes that took in almost the entire space around them. A small insect below did not even have time to realize what had come for it. In the air, the Meganeura had no rivals, no birds, no flying reptiles, no one at all. The sky belonged only to them, and this lasted an incredibly long time. It seemed such a creature was built flawlessly, down to the last detail. But it was precisely in this flawlessness that a deadly trap was hidden. It was too tightly, too inextricably bound to its world. It could not exist in any other air but this one. As long as that thick oxygen held, so did they. But the oxygen had no intention of holding forever. The change came slowly, almost imperceptibly, for a single generation. The Earth's climate began to shift, becoming noticeably drier and colder. The wet swamps that fed the enormous forests began to gradually dry up. The trees that gave the planet so much oxygen began to vanish in whole tracts. Scientists call this event the collapse of the Carboniferous forests. The once continuous ecosystems fell apart into scattered islands among dry plains, and along with the forests, the level of oxygen in the air relentlessly fell. Slowly, generation after generation, the atmosphere grew ever poorer. For most small animals, this was just another change one could adapt to. But for the giants of the sky, it turned out to be a sentence they could no longer appeal. And here lies all the cruelty of this story. The giant insects could not simply shrink over a couple of generations. Their entire body was built for a world rich in oxygen. Now there was no longer enough of that oxygen to feed their former size. The very tubes that once gave life could no longer do their job. A large larva suffocated before it could even grow into an adult. Only the smaller ones survived, and with each generation, the giants shrank. The creatures became prisoners of their own perfectly fitted bodies. Bodies made for an air that no longer existed and never would again. According to one of the main hypotheses, it was precisely the drop in oxygen that dealt them the decisive blow. Scientists still argue over the details, and there is no exact answer yet. But the overall picture looks surprisingly convincing. There remains one question, perhaps the most uncomfortable of all. Later in the long history of the Earth, oxygen levels rose again more than once. So why did the giants of the sky never return to our skies? The answer, likely, is that their place in the air was already taken. While the insects remained chained to their rigid limits, others rose up. First flying reptiles, and then birds, confidently claimed the heights. They breathed with lungs and did not depend so desperately on an excess of oxygen. Large prey in the sky now meant an encounter with a far more advanced hunter. Even if the old air returned, a giant insect would have nowhere left to fly. The narrow window in which they could be giants had quietly closed forever, and a second such chance evolution never gave them again. Today, looking at a small dragonfly over a summer pond, it is hard to believe in its past, but in its thin, trembling wings is hidden the memory of a world that no longer exists. A world where the air was thicker, the forests taller, and insects ruled the sky unchallenged. These giants were not weak, and they did not lose in a fair, open fight. Something else destroyed them. They fit too perfectly into one single world, and when that world vanished, they inevitably vanished along with it. Perhaps it is in this that the main lesson of the ancient Earth is contained. Perfection suited to one climate easily becomes a trap when the climate changes. And our own air, however eternal it may seem, is changing right now. What do you think? If oxygen on the planet rose again, could the giants return? Write in the comments what you yourself think about all of this. But how can we be so sure that oxygen was truly the key? The clue does not come only from fossils in the rock. In our own time, scientists have tried to test this idea directly. They raised ordinary insects, including dragonflies, in sealed chambers with enriched air. And in that thicker, oxygen-rich atmosphere, something strange happened. Several generations grew visibly larger than their normal relatives outside. It was as if the ancient world had briefly returned inside a laboratory box. The experiment did not recreate the true giants of the past, of course, but it showed that the link between breath and body size is real. The air really can decide how large a living thing is allowed to grow, and that quiet result echoes a truth that is 300 million years old. What the atmosphere gives, the atmosphere can just as easily take away.